Hello, everyone. Welcome to my second part video tutorial for MERfish dataset analysis. In this video tutorial, I'm going to use the MERfish Giotto object we analyzed in the first part and show you how to identify marker genes, then annotate the cell clusters. After cell cluster annotation, I will show you how to visualize the annotated cell clusters on UMap plot and also on the spatial images. So to identify marker genes for each cell cluster, we can use the find markers function one against the wall to identify marker genes for each cell cluster. If you watch the first video for MERfish data analysis, you probably remember we have 13 cell clusters in this Giotto object. So we can run find the marks function and use the Gini method. In the metadata, the cluster column name is Nathan 0.2200, so we can set the cluster column name here. Now we can find the markers for each cell cluster. Let's run. You can see it starts with cluster 1 until cluster 13. So we identify the marker genes for each cell cluster. You can see we generated a new data frame named as the markers. We have 607 gene names here in the data frame for 13 cell clusters. We can click the data frame and have a look at the data information. You can see the first column is the features. They are the gene names. Second column is the cluster name. Then we have the expression, gene expression. In total, we have 10 columns here to show the data by gene method analysis. So next, we can use the wiring plot or heat map to show the marker gene expression level in different cell clusters. Because we have 607 genes here, we cannot show all of them on the wiring plot or heat map. So we can select the first two genes for each cell cluster to make the wiring plot. Let's select the first two genes for each cell cluster. We can run. You can see here we have 26 genes because we have 13 cell clusters. You can see we select two genes for each cell cluster. So we selected 26 genes. You know we have different subpopulations in the neuronal cell population. We have different subpopulations for the oligodendrocyte. So the same gene could be selected as a marker gene for different subpopulations. So we will have the repeated gene names. Because we are going to set the gene names as row names for the wiring plot or the heat map plot, so we need to use the unique function for get rid of repeated gene names. So let's run the unique function for the 26 genes we selected for wiring plot. If we run, you can see now we only have 21 genes. So there are 5 gene names or repeated gene names. Now we can make a plot for the 21 genes to show their expression in different cell clusters using the wiring plot. Let's run. You can see we generated a wiring plot. We can zoom in. So on the right hand side are the gene names. Actually, the wiring plot is more difficult to look gene expression in different cell clusters, I prefer to use the heat map. So next we can run the heat map. You can see now we can select 6 genes for each cell cluster because it is easier to plot more genes on the heat map. And also we need to use the unique function to get rid of repetitive gene names. Let's select the top 6 genes for each cell cluster we can run. You can see here now we have 51 genes. After getting rid of the repetitive gene names in different cell clusters, we can make a heat map to show the expression level of 51 genes in different cell clusters. Let's make the heat map now. We can zoom in again. You can see it is much easier to see the gene names on the heat map. We have 51 genes here. The high expression value were indicated by the red color, so you can clearly see the marked genes for each cell cluster by the red color. So if you are analyzing your dataset, you should know the best marked genes for your cell clusters. The find max function can help you to identify the marked genes, but you will need your knowledge to know which gene labels which cell type. For example, here we can see MERfish because this is a dataset from the mouse brain. So MERfish normally labels the oligodendrocyte. You can see here SST and CCK expression. So both SST and CCK are neurotransmitters. So they label the neuronal cell population. You can read the previous published papers for immunohistochemistry, single-cell RNA sequencing data analysis to understand the best marker genes for different cell types. So according to the marker genes we identified from here, and also the online tutorial, we can name the cell clusters from cluster 1 to 13 as inhibitory neurons, excitatory neurons, astrocyte, mature oligodendrocyte, and endothelial cells. We also have the ependymal cell population, microglia. So we can name the cell clusters according to the cell type name listed in here. Let's name the cell clusters. And also we know the cluster name in the Giotto object at the moment was named as number 1 to number 13. So we need to match the number with the cluster name we list here. Let's give the number to each cell cluster. If we have a look at the cluster names now, you can see number 1 is inhibitory, number 2 is inhibitory, number 3 is excitatory, then 4 is astrocyte, 5, 7, 13, they are mature oligodendrocyte. So we got the cell cluster names ready. Now we can use the annotate Giotto function to annotate the cell clusters. The object will be MERfish object. Annotation vector will be the cluster names. We just set it here. Then the cluster column is the Nathan 0.2 to 100 column. We have the cluster numbers in this column. So we can give a column name as the cell types in the metadata to save the cell type information for each cell in this object. So let's annotate the cell clusters now. After the cell type annotation, we can visualize the annotated cell clusters on UMap. Because we named the metadata column as cell types, so we can count the cell clusters, use the cell type information in this column. Let's run a 3D plot to show the cell clusters with our annotation. We can run. You can see we generated a 3D plot. Let's zoom in. And we can make it bigger. So now you can see we named the cell clusters. Because this is a 3D image, we can hold the image and move it around to see different cell clusters. You can see the mature oligodendrocyte, inhibitory neurons, excitatory neurons. We have the astrocyte here, the ependymal cell types, and the endothelial cells are here. Microglia is here. You can see the 3D view image is beautiful. That's why I recommend you to use the Giotto package to analyze the spatial dataset. So this is our annotation. If you remember, we have the metadata when we download the dataset. So in the original metadata, it enables the oligodendrocyte or neurons in different subclusters. For example, it has 4 mature oligodendrocytes. It named as mature oligodendrocyte 1, 2, and 3. So I modified the metadata and just use mature oligodendrocyte for different subclusters and also for the endothelial cells and the neurons subpopulations. If we have a look at the metadata now, let's run. You can see this column is named as the cell types. That's our cell type annotation we performed today. And here is the latent 0.2, 200 cell cluster name. You can see they are named by the numbers. If you go up, because we added the original cell types information from the metadata, so in this column, we can find the original cell types. You can see the original annotation very similar to our annotation, but you can see this one. In the original annotation, it named as ambiguous, but here we named as excitatory neurons. The reason is that we didn't use higher resolution. They have more cell clusters, might be separate these cells into a different cluster, then they can name that cell cluster. So I showed you how to annotate the cell types. In the following demonstration, we are going to use the original cell types annotation to show the cell types on the 3D tissue. Because the original cell type annotation might be more accurate than our annotation, so we can plot the UMap 3D cell clusters using the original cell type annotation. We can run. Let's zoom in to see the cell clusters. You can see the cell cluster names are very similar to our cell type annotation. Again, I like to hold it and move around to look at the cell clusters in 3D view. Under the 3D view, you can use it to make a movie. It will be a very good movie to show your data. So now we named the cell clusters. You can see the cell cluster name on 3D view. Next, we can plot the cell clusters on the 3D tissue. Again, we are going to use the original cell types. Let's run the 3D spatial plot. Then we can see the cell canisters on the tissue. We can zoom in again. You can see we make it smaller. If you hold the 3D image and move it around, you can see different cell types. They are indicated by different cell color. We have the cell canister name on the right-hand side. Here, you can connect each cell canister to switch on or off for the cell canister in the 3D tissue plot. For example, we can switch off the ambiguous cell cluster. Let's switch off all of them. You can see all the cell clusters are gone. Then we can switch back the ependymal cell cluster. You can move around. You can see from the position of the ependymal cell types. You can see this is the correct cell type annotation. If you want, you can put the oligodendrocyte cell types in. So you can see from my demonstration, you can make a different combination to show the different cell clusters. For example, we can switch off the oligodendrocyte, then show the endothelial cells together with the parasite. You can see most of the parasite show close position to the endothelial cells, because normally all the parasites are attached to the blood vessels. So I showed you, you can switch on off different cell populations here. Another way to do this is you can actually just plot individual cell types. For example, here we want to show the excitatory neurons population. Then we can use the select cell group argument as excitatory neurons and set the few other cell types argument as false. Then we only plot the excitatory neurons in the 3D spatial plot. Let's run. And we can zoom in. You can see now on the plot, we only show the excitatory neurons subpopulation. Here we only plot the one cell type. You can use combination to plot different cell types. For example, here we want to plot the astrocyte and the oligodendrocyte. Then you can put the cell types name in the select cell groups. Then we can plot the three cell types together. Let's run. Let's zoom in again. You can see now we see astrocyte, mature and immature oligodendrocyte on the 3D spatial plot. You can see I showed you we have 12 sections here. You can also plot the cell types on selected tissue layers. Let's select some examples to do the demonstration. Now we are going to plot the cell types on different tissue layers. Again, we know the tissue layer ID in the metadata. We can have a look at the tissue layer ID again in the metadata. You can see we can use the tissue ID here. We have 12 tissue ID to plot the cell types on different tissue layers. So for the demonstration, I'm going to use the tissue layer 210, 110, minus 90, and minus 190. If you want to try, you can set a different tissue layer ID here. So for the first one, we are going to plot all the cell types, the original cell types on 4 layers. We can run. You see, we generated the image to plot all the cell types on 4 layers I selected for demonstration. We can zoom in to see the cell types. You can see here we show all the cell types on different tissue layers. Once again, we can select the cell types. For example, we just want to plot the excitatory neurons. Then we can use the select cell groups argument to set the cell types that you want to plot. So now we can plot the excitatory neurons on 4 layers. We can run. You can see now we only have the excitatory neurons population on the 4 layers we selected for demonstration. If we want to make a combination to plot different cell types, for example, we want to plot the endothelial cells, parasites, and the ependymal cell population, we can plot all of them together on 4 layers again. We can run. Let's zoom in. You can see now we have the endothelial cells, the ependymal cell population, parasites population on 4 layers. So you can see the advantage for using the Giotto package. I think the Spatial 3D plot function make the Giotto package a very attractive package for spatial dataset analysis. I hope you see the advantages for using the Spatial 3D plot from my demonstration. Because the advance of the spatial genomics technologies, I believe more 3D spatial dataset will be generated in the future. So you can use this package to analyze the 3D spatial dataset. Okay, that's my demonstration for MERfish dataset. I hope my video tutorials could help your data analysis. Please subscribe to my channel and share my video tutorial with your friends. Thank you.